One of the most challenging things with power series is when you get away from the um, simpler function and into the composite ones. The first thing you need to know before you go any further is all of the following functions. These should all be memorized, or you should be able to derive them actually fairly quickly at this point in time. So once you can identify one of the elementary functions, you may need to add, subtract, multiply, divide, or use a composite relationship to find the power series for your function. For example, suppose I want the power series for f of x is equal to cosine of the square root of x. I don't want to do these derivatives, but I know that the expansion of cosine of x is 1 minus x squared over 2 factorial plus x to the fourth divided by 4 factorial minus x to the sixth over 6 factorial, etc. So if I replace the square root of x, everywhere I have an x, I see the cosine of the square root of x is 1 minus the square root of x squared over 2 factorial plus the square root of x to the fourth over 4 factorial minus the square root of x to the sixth over 6 factorial, or 1 minus x over 2 factorial plus x squared over 4 factorial minus x cubed over 6 factorial, and we could keep going on. Now, where is this going to converge? It's going to converge wherever, cosine of x converges for all x. However, this one will converge for all x in the domain. So this is going to be when x is greater than or equal to 0. Now, what if we want to look and find the first three non-zero terms of the Maclaurin series tan x? Now, tan x is not one of the ones in our table. So let's see, what can we do here? I know tangent of x is sine x over cosine x. Now these two are in my table. I do have these memorized. So sine x is x minus x cubed divided by 3 factorial plus x to the fifth over 5 factorial, etc. And that's divided by cosine, which we just did, 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial, etc. Now, what you know with this one is long division. I'm sorry, it is a mess. I think these were easy. So I'm going to have 1 minus 1/2 x squared plus x to the fourth over 24 plus etc. And I'm going to divide that into x minus x cubed over 6 plus x to the fifth over 120. The good news is you really only need to go to the first 3, maybe 4. So 1 goes into x times. So this is x minus x cubed over 2 plus x to the fifth over 24 plus. So I subtract these. And I get, that goes away, so I get 1/3 x cubed minus 1/30 x to the fifth. All right. So what do I need here? So now I need to multiply by plus 1/3 x cubed. Let me give myself a little room here. So this is 1/3 x cubed minus x to the fifth over 6. Now I subtract all of this. And I'm left with ugly, but that's okay. 2 divided by 15 x to the fifth plus. Now you see I only want the first 3 terms for this one. So this is going to be plus 2x to the fifth divided by 15. all right, plus. So because I only wanted the first three terms, I'm actually in good shape. So the first three terms of tan x are x plus x cubed over 3 plus 2x to the fifth over 15, first three non-zero terms. The next trick I want to show you is when you have to deal with a power series expansion of something like sine squared of x. The easiest way to do this one is to notice that sine squared of x is 1 minus cosine of 2x over 2. All right, so this is 1/2 minus 1/2 cosine 2x. 1/2, there's no expansion there, but I remember that cosine of x, this is one of my fundamental functions, is 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial. I don't know what's wrong with my thing here. I apologize for that. X to the sixth over 6 factorial, etc. So cosine of 2x can be written as 1 minus 2x. So this is 2 squared x squared over 2 factorial plus 2 to the fourth x to the fourth over 4 factorial minus 2 to the sixth x to the sixth over 6 factorial, and we keep adding. So I'm going to take this and put it into sine squared of x. Well, it's 1/2 minus 1/2 times this expansion. 1 minus, so what is this right here? So this is 2 squared. Let me go on and leave it this way. I know this is tedious. You can go and multiply it out. All right, so when I rewrite this, what do I have? I have 1/2 minus 1/2 plus, all right, I left the 2's in there for a reason because I knew I had this 2 on the outside, 2x squared over 2 factorial minus 2 cubed x to the fourth over 4 factorial plus 2 to the fifth x to the sixth over 6 factorial plus. How many terms did I want? The first three? Those go away. Those are going to cancel. And so this becomes x squared minus, and yes, I can simplify this down, but I don't want to. Two to the fifth x to the sixth divided by 6 factorial. First three non-zero terms of sine squared x.